Next, when there is weld joint, you will need to check for the weld resistance of the connections. There is no welded joint for the tensile splice, and the bolted weld clip will be fully on the bolted joint. There will be only the connection B, which is the bolted end plate, having the welded joint between the plate and also the width of the beam. With that, you will need to check for the weld resistance of the connections for the bolted end plate connection. And then you will need to check for the shear resistance of the end plate, as well as the shear resistance of the angle for the beam to column connections. This is to check against the shear plane of this end plate, as well as the shear plane of the angle here. Also, for the bolted end plate connection here, since there is a weld between the end plate and the width of the beam here, you will have to check for the shear resistance of the beam width. This is not required to be checked for the tensile splice or the bolted weld clip connection. As for the bolted weld clip connections, there will be bolt holes onto the web of the connections. With that, you will have to check for the bearing resistance of the beam web, which is located here, deemed to be the most critical bolt hole. And because there is an offset distance of the vertical force to the surface of the column, these connections will generate an additional moment load acting on it. This will lead to an additional horizontal force and forms a new resultant force, which will be more critical than the other bolt holes. With that, the force needs to be recalculated as per the resultant force, instead of using the vertical shear force only. And this force will be checked against the resistance in terms of the bolt in shear, as well as the bearing resistance of the angle and also bearing resistance of the weight for this connection. Lastly, you will have to check for the block tearing failure. For the end plate here, the block tearing failure will be here, and for the bolted weld clip, the block tearing failure will be more critically at the width of the beam. You will need to imagine the mode of failure for you to calculate the resistance. Also, bear in mind that especially for these two connections, which seems to be one connections, in fact, it can be separated into the connections between the beam and the plate and the column, or the connections between the beam and the angle and the angles and the columns. This list of the area to be checked will have to be in line with every single one of the joint at the connections. You may choose to check all the connections, or you will need to identify the regions which is more critical and focus your check against the critical situations. What you see here, the design of the connections for the steel structures is quite complicated, as it involves many components and there are interfaces between different components. And what you have learned from these chapters is only 3 common types of connections, mainly made of the bolted connections. There are other more connections, which some of them can be moment resistance. This will lead to the other scope of checking, which is not covered by this chapter.